Welcome to this topic video on NeDB for Node, but it's really about data persistence and NoSQL databases in general. We're going to use one particular one to illustrate things, but it has an interface that is similar to others. Okay. References. Okay. NoSQL, what is it? Wikipedia let you know. Specifically document-oriented databases, not a bad article. What is MongoDB from the MongoDB people, and the documentation for NeDB, the little database. That can. Okay, so why? Part of a server's job is to be a data repository. Okay, we keep data on the server. Those can be web pages, they can be templates, they can be CSS files, images, and user data. Okay. Why a database? Why not just keep a bunch of files in the file system? Yeah, why not? Well, databases bring organization and fast lookups. Okay. Good for lots of little data, rather than a file per item. Okay, any of us who've been using NPM and Node for a while, we notice that those Node modules, our Node modules directory, has quite a few little files in it. Okay, file systems don't particularly like it when you have a ton of teeny files. Okay, they get slower. Okay, not true for databases. Okay. So when we have lots, and I mean lots of little data, databases really shine. Okay, you're not going to be the database. Okay, now that's saying it doesn't use a file system, it just doesn't use it the way we do. Okay, types of databases. Okay, the traditional high performance databases used in business and elsewhere are relational. Okay. The data has to be highly structured, and if you take a database class, they'll show you how to do procedures to structure your data in a way that's optimal for relational databases. Typical open source examples: Postgres SQL, okay, and SQLite. Okay, SQLite. Okay, actually, you get a copy of that when you get Python. Okay, part of the batteries included with Python is you get underneath an SQLite. Okay, document-oriented databases are less structured and more flexible than relational. These are also sometimes just grouped under the category of NoSQL. Okay. They're relatively easy to get started with. Examples include CouchDB, MongoDB, NeDB, the small database we're going to use. Okay. Other types of databases, graph databases that generally are used with GraphQL. Okay. Now, databases have some fundamental operations. Okay, both SQL and NoSQL. Known as CRUD. That's not an insult. Okay, that stands for create new items in the database, read, look up, and search and get things out of the database, update things that are already in the database, and remove things, delete things from the database. CRUD. Okay, so that's what that stands for. Okay. So we're going to use an example document database, okay? And it's written in JavaScript, so we don't have any installation hassles. We don't have to do any separate programs. Now, for big jobs, this is not appropriate, okay? This is good for JavaScript only, okay? It's a subset of the API that's used with MongoDB, and it's plenty fast, but it's 100% JavaScript. We've got no installation hassles, okay? Goes in easy, okay? npm install NeDB -- save. Okay. And remember, when we do this stuff, we're really assuming that you've set up a package JSON file, so this gets put in that package JSON. I've got all the examples you're going to see in a zipped archive that you can download from the website. Okay. Let's get down into it. Let's create a database and store some things in it. Okay. In NeDB, a database, a DB, or data store, is like a JavaScript array, and it can hold arbitrary JavaScript objects. Professor, yeah. Haven't we been using arrays of JavaScript objects all semester long? Yep. So you're telling me that same model is going to be used with these document databases like NeDB and MongoDB? Yeah. A MongoDB collection, okay, is modeled after an array of objects, okay? NeDB, like MongoDB, provides many methods for inserting, updating, finding, and removing objects from these stores. Okay, you can use multiple of these stores in an application to hold different types of data. Okay, so what did we say again? It looks like a JavaScript array holding JavaScript objects. Okay, and designing these NoSQL databases is different than the techniques that you'd use to design relational databases. You more think of in terms of what data you want to get together at the same time rather than doing the precise optimization type of stuff you do with relational databases. So it's a different criteria. You can have multiple data stores, okay, and you determine how you want to break up what data goes where. We'll see an example coming up. Okay. Now, as usual, we're doing this on the server side. So this is in Node. I'm not saying you can't use this in the browser side, but on the browser, there's actually some good database features available that are kind of like a NoSQL database. Okay. But we're not talking about that here. Okay. So we require it. Then new data store, blah, 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 blah. Oh, we're binding this to a file. We're still using the file system. What we're not doing is generating lots of little files, okay? The database, part of its job is to efficiently pull things in and out of these files and such like that, okay? So we can back up. Okay, NeDB can act in memory or file-based. We're trying for persistence, so we want file-based use. That's why we're telling it a file name to use when we give it this set of options. Gotcha. So how to create documents. Okay, every document in the data store, every object that we're going to put in this data store, which looks kind of like an array of JavaScript objects, needs an ID property. Oh, that's how we're going to identify these things. It must be a string, and it must be unique. Oh, and like other databases, you can have the database program itself generate these for you, or you can do it. Okay, so let's take a look. Inserting documents, a single insert. Okay. Data store require, bind it. Okay, let's single insert. Let's see if we can find this guy. Simple DB finds. Oops, I don't not have that one. We've got the more elaborate one. Okay, so that's inserting one item. What do we say? DB insert log. Now, as you might guess, we may want to insert multiple documents, okay? So we're going to take a look at this case. Batch insert. We have multiple of what are these? They're kind of blog posts. Title, Python, Snake, or language. Content. This will be the blog content. Right now it's a placeholder. Okay, and notice I'm using numbers here, but they're strings. Okay, they're in quotes. Okay, so I'm giving each one of these things unique thing. I can do an insert. Oh, instead of just one item, I give it an array of items. Okay, so let's take a look at this. This one we'll really take a look at. Simple insert. Okay, set up NeDB DATASTORE. Remove the file blogdb before running this example. So we go over to the examples and we look at blogdb, and I don't see anything named blogdb by name. Okay, nothing with the blog. Okay, so we're good to run the example. Let's run the example. Okay, node simple, what's it called? Simple DB init. Added 3 documents. Great, Professor. How do we get to them? We'll see. Okay. Or we can let NeDB assign the IDs. So here, we're going to bring in a whole bunch of data from a JSON file. Then, and this will be an array. So we're going to feed this a JavaScript array. Okay. In this case, these guys aren't going to have any IDs associated with them. NeDB will see that and will assign them. Let's take a look at this data. So this is Narantapu. So this is a bunch of data about animals. Okay, scientific name, common name, platypus, common name, swamp, and I can't even pronounce the common name rather than that. Down in here somewhere we'll see brown bandicoots, we'll see eastern pygmy possum and stuff like that. This is a national park in Tasmania, so they have cool and unusual animals, like a platypus. Okay, so that's what that data is like. Now, what program are we looking at? TasDB init. TasDB init. Okay. Remove the TasDB before running this example. Not strictly true anymore because I put in a command so it's easier to update. I put in DB remove everything from the DB first, so we can run this example without having to do that. Okay, so let's do it though. Okay, let's run this example. Okay, so node has db init, clearing database, removed 20, added 20 mammals. Okay, so we were able to put all those things in. Okay, node on example. If we didn't say this enough times, Node makes it easy to import JSON files into a variable. Okay, so this is part of that file we said before. Okay, this if I import it with the require statement in Node, it'll get pulled in. That's nice. Okay, the data is from the Tasmanian Parks and Wildlife Service, so I thank them. Okay, now let's take a look at these file formats. We don't need to do it through the slides. Let's look at it directly so you can believe it. Okay, so let's look at, what did we say? BlogDB. This is the raw file format. We don't touch this, okay? So it's put these things in and put these things in order, and we're seeing it before there's any changes or anything, because they'll keep various pieces of information here to account for changes to these files in an efficient way. We don't mess with these files. But as we see, it created things as we told it to with that ID. Now, let's go look at the TasDB. Oh, it put in these big IDs for us. Made sure they were unique in their strings. Okay. Gotcha. Okay. But once again, we don't mess with the file format. They will maintain the file in an efficient way. Okay. So we saw one case where we assign the IDs, another case where we let NeDB assign the IDs. Okay. Now we got some data. Let's search through it. Okay. We can use the find method to look for multiple documents matching your query, or find one to look for one specific document. Okay, you can select documents based on field equality, or use comparison operators. Now what's cool here, and this is the same as what's done in MongoDB, is they put all this stuff looks like JavaScript objects, even the way we specify a query gets put into JavaScript object form, which the database engine will then process for us. Okay, so we're going to see some interesting looking syntax here. Okay, you can use regular expressions, okay, which are covered in other classes. Okay, so I won't go too much into them. In place of a string, or you can use a regex type operator. Okay, so let's look at how we find a document. First of all, if you give it an empty search object, it'll just get you all of them, get you everything out of the database. Great, good. Okay. Oh wait, what's going on here? Oh, it uses a callback function. So this is asynchronous operation. Oh, that's right, because file system stuff can take time, so they want to be efficient, and Node.js provides for asynchronous file system operations, so they are giving us a callback interface. Okay. We know callbacks can get complicated, but let's stay with this. Okay. So other ways to find things in the data store, look at this. Okay. Here we say, here's a search string. We say, look for common name. Oh, and this is one of these regex type of things, regular expression things in JavaScript. That's just JavaScript syntax. We haven't seen it before. Okay, so let's take a little bit look. Okay, MDN has a good guide to JavaScript regular expressions. Okay, and they're very useful for searches. The problem is they're very terse and they're easy to make mistakes. So what I do, not only do I read this, I go to there's some online regular expression sites that will have regular expression testers that will do regular expression syntax with the different language quirks, right? Because Python regular expressions are different than JavaScript, etc., are different than other places, okay? So you make sure you use one of those test tools to refine your regular expression and test it well, okay? Okay, simple kind of things. A regular expression is stuff between slashes, okay? Caret, this thing matches the beginning of the line. This matches the end of the line. Matches 0 or more of the preceding characters, or matches 1 or more of the preceding characters. So, and there's a lot more of these rules, okay? And they can do a lot of cool stuff. Now we can try these out right in our browser, okay? So, we're going to just copy this, paste it. Oops, not that. Resume presentation. Hit the wrong button. Control V. Okay, we don't need to see all these different things. We're just going to have a string. Okay. Then we're going to use the match method that takes a regular expression. Do we have something in this string that matches A? Oops. My string is not a function. No, it's not. We forgot the dot match. Okay, so there's something that matches A. Is there something that matches a mess. Oh, oops, what am I doing wrong here? This mess, that should match something. A mess. No, it's doing autocomplete on me. Here. So it matched and found and the S. Okay. I can look for instead of that, let's look for and see, can I find this in the string? Oh, it found this. Can I find this at the beginning of the string? Yes. Ooh. Can I find this right at the end? No. Why? Because this isn't at the end, this is at the beginning. If I put in web, ooh, it found that. Okay. So these are regular expressions. JavaScript has big support for them. Okay. If you haven't seen them before, don't sweat it too much. Okay. Now, we can use them for query operations. Okay. So find, ooh, look at this. Okay. Before, we said common name possum. We wanted to find everything that was a possum. Okay. Here, now all this syntax I don't memorize. There's a guide to it. Okay. And this is the same way that MongoDB works and NeDB works. Look at this. We have an object here, starting here, and it has a field, a property name, or. Then we give it an array of objects, search objects. Oh, this is going to match everything that has a common name of kangaroo or a common name of wallaby. Oh, so we can put together complicated queries. Okay. Like database people are used to. If you're not used to it, don't worry. You can put together complicated queries. Okay. Now, let's try running some of that search. Let's go look at find animals. Find animals. Okay. So here we're going to get, so right here, empty query means we get them all. Here's where we go and get the possums. Okay, we'll look for the common name that has possums in it. Here we're going to look at the common name where it doesn't have bandicoot in it. Okay. Here we're going to use that more complicated syntax. But notice, this is just a JavaScript object containing a field or, which then is an array, and each one of those is a search criteria. Oh, this is how they use just JavaScript object to specify a complicated query. And note, for those in my class, this is the same syntax for NeDB that gets used as a subset of that gets used in MongoDB and other document NoSQL databases. Okay, so let's run this and see if this will really work. Okay, find animals. Node find animals. Oh, we found two kangaroo-like things, a Bennett wallaby and a Forester kangaroo. We found two types of bandicoot. I don't remember what those look like, sorry. Okay, Eastern barred bandicoot and a brown bandicoot. Okay, I think this is a mammal that's generally smaller than a wallaby and such like that. We found three types of possums. Okay, ringtail possum, brushtail possum, and eastern pygmy possum. And then, of course, at the beginning, we did a search and we found total all the things. I have The database has 20 animals in it. Oh, okay. So we're not going to memorize any of this stuff, but no, it's got the full power to find all sorts of things in the database. This is what you want out of a database, okay? Okay, and you can use the various fields to help you, okay? Now, what else do you get? Oh, sorting. Pagination? If you're not a database person, you may be wondering what that is. Well, sorting, we know what that is. We can sort things. How are we going to sort things? Oh, we're going to do it by common name. Oh, and one means, I think, ascending, means increasing from low to high. I have to look that up. Now, pagination means, oh, we're going to limit it. Okay, so here then, I set this up. Okay, so here, I set up what I'm going to sort by. Oh, so it's going to find everything. Then it's going to sort. Okay, then it's going to limit. Ooh, that's that functional notation. Oh, and then, of course, it's going to run the thing. Okay, it's going to do all this stuff. So we're going to limit to 5, sort the thing. So let's try this one. Okay. Okay, let's get our top 5. Okay, node, sort, ag, animals. Ooh. First 5 sorted by common name. Okay, so these are the common names: Bennett's wallaby, Betong, whatever that is, a brown bandicoot, and a brush-tailed possum. Oh, and the common wombat. What else do we get here? Projections. Oh, that must be scary. No, it's a big word for a simple idea. Okay, let's say you don't need to get everything back from the database, all the fields back. You just tell it which ones you want. Okay, so find everything. Include in what you find, besides the ID, they'll always return the ID. Just give me back the scientific name. Okay, I say that by giving it a 1. Okay, we can also use reverse logic and say, give me everything but something. Okay, sort it by scientific name, limit it to 5. Okay, so this is the projection portion. Okay, it's so common that we don't want all the fields that they put it right up there as part of the find command. Okay, these are database operations. Okay, this is in the database class, but this gives you the idea of the power people expect from a database. Okay, as far as searching, sorting, limiting, and this was actually part of sort, paginate animals. So let's go finish looking at what was returned. Oh, first 5 sorted by scientific name. Notice we got the ID, but the only thing we got was the scientific name. And I'm not going to try and pronounce those. Okay. If I could have pronounced complicated names, I would have become a botanist and worked with plants. Okay, what else can you do? If you don't need all the details, you can just get counts of types of things. Okay, you just say db count, give it your search criteria. Okay, here we're going to count everything. Here we're going to count only the things that match or match criteria. Oh, so it's matching isn't just for, no, it's not just for find. You can use it with count. Ah, okay, let's try it. We got all these examples. And why do I have all these examples? So when I need to go do things, I can look up examples that are simple, that I wrote, that are easy for me to understand. Ah, here we go. Counted 20 mammals total. Oh, and we have one type of devil. Okay, there's only the Tasmanian devil. Okay. What else can you do? You can change things. You can update things. And by that, we can update not just the value, but update and add a whole new field. Okay. Here we're going to add and set a new field. Okay, so we're going to go look for the Tasmanian devil, or any devils we've got in here, but there's only one type. By common name includes devil. We're going to set a new field, status. We're going to set it to endangered. Okay. When we're done, we're going to write back, okay, updated Tas devil, and we're going to print out the document. Okay. We talk about this as a document-oriented database. So we're going to, after we do this update, it's going to give us back either an error message or no error and what we just updated. Oh, nice, Professor. Here, okay. Oh, sorry. We're going to look at that. Okay. Wait a second. Update. Okay. Let's go look at that in our text. I think we add the stuff in and then remove it. Let's look at update. Update animals. Ah, yes. A little bit more to it than that. Here, we're going to update, add in the status as endangered. Okay. Then we're going to look it up again and see what it looks like. Okay. Then we're going to do update and unset, remove this status thing from the database. Okay, so we're going to unset status endangered. Okay, let's run this. Okay, so a couple different updates. We're just returning them. Okay, so we said node update animals. Okay. Node updated Tas. Updated Tas. Now we've got scientific name, common name, the ID, and status endangered. Okay. Now we're going to update it again to remove that status. Okay. Updated Tas devil. Updated Tas devil. We print it out again. We're back to scientific name, common name, and ID. Hopefully we'll get the devils off the endangered list. All right. And the only reason they're called devils is because of the cry they make, or it sounds very bizarre. Okay. Otherwise, they don't come after people. Okay. Of all the things in Australia that'll kill you, it won't be a Tasmanian devil. Okay. Oops, updating. We just saw this. We removed the field. Okay. We can remove documents. Okay. Same thing like find. Which ones do you remove? Well, you give it a search criteria. However, do you want to just remove one or multiples that match the criteria? If you want to clear out the entire database, go multi-true. Okay. So what I did to enhance the TASI database init, I actually put that in here because that way I don't have to really tell people to remove the TASI database. This will clear out everything, okay, as need be. Okay, be careful with that, but when we're doing our development, you're going to be trying a lot of things, okay, and that's why I set up my database from a JSON file. Then I do things and stuff like that until I get confidence that things are working. Okay, what's indexing? NeDB supports indexing. Basically, if you have other fields besides the ID that you want to look things up with a lot, you tell it that, okay? And it'll give you a nice speed boost for finding things, okay? It can also be used to enforce unique constraint on a field, okay? You can index any field you like, okay? So that's how you can get more speed, okay? Now, callback interfaces. Didn't we learn something? Okay, so NeDB provides for asynchronous operations via callbacks, okay? We have learned that JavaScript promises can keep our code way more readable and straightforward, okay? NeDB promises provides a nice promise wrapper for NeDB, okay? Somebody did some nice work, so we have a nice promise wrapper for this thing. Okay, so we'll install it and use it. Okay, just a little bit different how we use things now, because we got to have NeDB installed, but then we install NeDB promises. Okay, we'll pull that in, then use. Okay. Oh, all these things like find one, insert, and such like that, they're thenable. They return promises. Okay, Professor. If they return promises, can we use async and await? Oh, yeah. Okay. So here, this is purely fictitious, okay, but the animals are real. I've come up with two databases. We've got the Tassie database of animals of Tasmania. We've got the user database, a database of recent national park visitors. Completely fictitious, okay? They don't track visitors that way, okay? This is just me, okay? Park visitors can register, I'm making this up, animal sightings via a web page. And we will add sighting information to both databases. And everybody knows in my class, I usually have us get practice with either forms or widget processing from JavaScript on HTML pages with an example like this, okay? So we're going to use this file settings, okay, in the NeDB example archive, okay? So first of all, I'm going to run a little programmy, okay? So I'm going to go node, what's it, as db init, okay? Make clearing database, removing it, starting nice and fresh. I'm going to go node user db init. This is my user database, okay? What am I creating my user database from? My usual, I've got fake user data that I created a long time ago, okay? Using a fake data generator, so none of these people are real. None of these passwords correspond to real sites, except the ones that we create in class. Okay, so that's what I just did. TAS database init, user database init. So let's look at this sightings code. Okay, okay. So it's going to be as simple as a sighting consists of two fields: the ID, the email of the person that cited it, and the scientific name. Why are we using scientific name? Scientific names are supposed to be unique. Okay, so that's all they're doing. And it's like, hey, wait, but who is this? And what did they see? I don't know. We're going to find out. Okay, and here's another sighting. This person saw this animal, whatever that is. Okay, so let's see how we process this. Okay, okay. Let's say putting these sightings in order was important. This is what I would do. Okay, so here I go. Let visitor equal await. Oh, I'm going to get the visitor's information. Find one. Email, oh, is equal to email. Okay, so this is a function. Okay, we're going to use this function multiple times. Okay, we're going to find the visitor. Okay, we're going to find the animal. Okay, and we're going to say visitor, blah, visitor first name, visitor last name, saw an animal with the common name. Okay, now we're going to update those things. We're going to go visitor db update email push onto sightings. Oh, we're going to have some array called sightings. We're going to push a value. Oh, so you can put, yeah, you can put arrays within these things. What will this be? This person will have an array of all the animals they've seen. Oh, and look, we're going to update the animals. The animals are going to have an array of all the people that have seen them. Oh, okay. And we did these in order. Did we need to do those two in order? Not really. They don't interfere with each other. Okay. Okay, let's run it. Okay, nice clean syntax. Okay, node sightings. Okay, so Scarlet Cantu saw a Forester kangaroo, but we haven't done the other one yet. Let's see what this other one does. Let's say we wanted to record these things in parallel. Okay, and how am I going to do that? I'm going to say, here are a bunch of promises. Visitors DB find the person. Visitors DB find the animal. Now we want to get both of these before we go on to update them. Okay, or so it seemed. So I said, let visitor and animal await promise all. Wait for both of those to finish. Okay. Whether or not you do these in parallel exactly, it depends what you're trying to do and trying to optimize. I'm just showing you an example. Now, update, okay, promises, visitor update, give the update command, Tazid updates, await for those things to finish. Now we can say that we've updated things. So we can use async and awaits. We can do async and await plus promises. We can go just with promises. What did that part look at? That was the second one here. Calvin Kemp saw a Bennett's wallaby. Updated one visitor and one animal. Updated one visitor and one animal. Why did those come out later? Because some of these things happen after the fact. Okay. Now, so we saw the parallel operations. So this was a whirlwind tour of a NoSQL database concepts with a JavaScript only database that has an interface similar to a very, very popular NoSQL database, namely MongoDB. Okay, and this is how we keep data on our servers, especially when we have lots of little data. All right, let's go code the web.